Hey guys, for the past 7 or 8 years, I've done a yearly guide to web development technologies, and I know that a lot of you guys really like that video, but the truth is not much changes from year to year in terms of actual technologies, and it was getting really repetitive. Not only that, but the amount of technologies is a little overwhelming. So what I want to do this year is break it up into different videos and guides based on a specific area or path in web development. That way I'm not giving you 100 different languages, frameworks, and paths in one video. So in this particular video, I want to do a complete roadmap and plan for full stack JavaScript developers, from the basics of web development to getting a job or freelancing or whatever whatever it is you want to do. I will have a specific freelancer's guide as well later in the year. Now, in these guides, I'll be breaking everything up into phases, and I'll give you a timeline for each phase. However, it's important to understand that this timeline can vary depending on different factors such as how much time you have to learn each day, your comprehension level, your current skill level, and so on. So take the number of months that I specify with a grain of salt. And I'll also have this entire presentation available for you to download in the description in PDF format. So this will be somewhat of a long video, so you can always play it in the background while you do other tasks. All right, so let's get into the roadmap on how to become a full stack JavaScript developer. This video is sponsored by Sentry. So as developers, we've all been there. You ship a new feature and suddenly errors start rolling in. But digging through endless logs to find the issue can be a nightmare. And that's where Sentry comes in. Sentry's error monitoring instantly alerts the right developer the moment something breaks. So no more soul-crushing log sifting. You get detailed device data, browser info, and even a session replay to see exactly what the user did before the error happened. And it's not just for errors. Sentry's tracing lets you debug performance bottlenecks across your entire stack, so you can fix slow APIs or laggy UI just like you would an error. Plus, their AI autofix is getting really good at handling repetitive fixes, so you can focus on the real problems. So start using Sentry today and get 3 months free on the team plan with my promo code Traversy. That's 150,000 free errors. So sign up at sentry.io/signup or click the link in the description. All right, so I've broken this roadmap up into 5 phases, and when we get to each phase, I'll explain more, but just to give you a quick overview, we have phase 1, which is the foundations of web development. Phase 2 is front-end essentials. Then we have back-end and full stack. Phase 4 is career development, and then phase 5 is continuous learning. So let's start at the very beginning, which is foundations of web development. And this is where you're going to learn the essentials that absolutely every web developer is going to learn. And I don't care if your goal is to be a WordPress developer or you want to create really complex full stack apps, you're going to start in this same general area. And I gave this phase 1 to 3 months, or I should say months 1 to 3. Meaning that you'll start here, and after the 3rd month, you would move on to the next phase. Now, again, this timeline may be different depending on your situation, and I made it with the assumption that you'll be spending a good amount of time each day learning. You can't just study for 2 hours every Saturday and learn what you need to in 3 months, so keep that in mind. If that's your case, then it would extend longer than 3 months. Now, before you actually start learning web development, spend a little bit of time thinking about how you're going to learn these things. I'm guessing most of you are going the self-taught route, so in addition to knowing what you need to learn, you need to know how to learn it. And there's many different methods that you can use. Some work better for different people. For instance, I'm not much of a book learner, but I know some people that have learned everything they know from books. I'm more of a hands-on project-based video learner. That's why I teach the way I do. So for each topic we go over, you may want to make a list of courses, YouTube videos, books, documentation, whatever it is that you want to use to learn. Another thing that I'm a little hesitant to push on people at this stage is AI. ChatGPT it's an amazing helper. I use it all the time as kind of like a coding partner, but it's easy to become too reliant on it. So as a beginner, I would say use it as a supplement to where if you really don't understand something and the video or book or whatever wasn't clear enough, then use AI to kind of clarify and explain further. Just be careful not to use it too much and not to have it be a crutch. And, if you're interested in using my courses to learn this stuff, I'm going to add them in the description in the order that I talk about this stuff. All right, now in terms of technologies, you're going to start off learning HTML, which is the standard markup language of the web. And this is how we structure our web pages. We use HTML tags and attributes. You'll learn basic heading tags, paragraphs, links, etc. But the most important part of learning HTML, in my opinion, is learning the semantic layout and structure. You want to use the right elements in the right places, the header tag, the main, section, footer tag. Learn when and where to use those. Now you'll start learning HTML, but pretty quickly you'll also start to learn CSS, which is a style sheet language. And HTML on its own you can think of as like the skeleton, and you need CSS to actually add styling. And there's no website built with just HTML and no CSS. So these two you'll really be learning together. Now CSS is all about selectors to select certain HTML elements that you want to style, and then using properties with certain values. So some really important parts of CSS to focus on would be the box model, which has to do with margin, padding, borders, and content, and how these work together in layouts. Flexbox and CSS grid are really important. This has to do with how you want your content positioned and laid out within rows and columns. Responsive design is really important so that your layouts look good not only on computer monitors, but also tablets, smartphones, and even TVs. Now, once you get down the essentials of HTML and CSS, I would suggest creating some kind of landing page. This screenshot is from my Modern HTML and CSS course, and it's a landing page for a fictional mobile app. And it uses all the aspects of HTML and CSS that I just mentioned. And I'll have a link to that course and others in the description. However, I would suggest even if you take these courses, whether it's mine or someone else's, and you build these projects, I would still suggest creating something on your own from scratch without the hand-holding of a course. Now, once you're able to create decent looking static websites with HTML and CSS, I would suggest jumping into Git. I think this is a good time to do that. And Git is a version control system, and it's used to track changes in your code, collaborate with others, manage different versions of your project, and at the very least, it allows you to back up your code and save specific versions or states of your project. And Git consists of learning a bunch of different commands to do things like add your code to a repository. A repository is like a storage container for your code, but it's also like a time machine because it stores multiple versions. And you can create different branches and do all types of cool stuff. Now, along with Git, which is the version control system, you should learn GitHub, which is a web platform to store your repositories, as well as collaborate with others and allow other people to work on your projects and add to your repositories. There's other platforms like GitHub. So for instance, GitLab, Bitbucket. So there's a bunch of them, but GitHub is by far the most popular. So I would definitely recommend learning that. All right, so you can build static websites, you can push them to GitHub, but what about making the project accessible online? You need to be able to deploy your websites to a hosting service so that people can actually visit them. And there's all different types of web hosting. When you start getting into complex applications with databases and stuff like that, deployment can be pretty complex as well. But for like a personal website, a blog, there's services where you can simply select your GitHub repo from within the hosting dashboard, and it will deploy it and put it online. And two really great services for this is Vercel and Netlify. And they both have free tiers for small personal projects. You can even run server-side code using something called serverless functions. That's not something you would get into just yet. Another thing that you'll need to learn is how to purchase a domain name and link it to your website. Now, when you use a service like Netlify, it'll give you a domain that would be something like whatever, mywebsite.netlify.app. But for any professional website, you're going to want a custom domain name of your choice, and you can use any domain name registrar for that. There's a bunch out there, but I've always used Namecheap. It's easy to use, and the domains are cheap. So you should be able to, build a website with HTML, CSS, push to GitHub, and make it live at this point. Now, when I say static website, I just mean a website that displays information like a brochure. In order to make a site dynamic and interactive with forms and stuff like that, you'll need to learn JavaScript, and that's the next step. So JavaScript is the programming language of the front end of the web, and HTML and CSS are not programming languages. They're the building blocks of a web page, and they're extremely important, but they don't have logic, so they're not programming languages. With JavaScript, you'll be learning programming fundamentals like functions, variables, arrays, loops, and much more. And you use these aspects along with something called the document object model, or the DOM, which is basically a representation of the web page that JavaScript can interact with. And the DOM allows you to select, modify, and manipulate HTML elements dynamically. So for example, you can use JavaScript to change the text inside of a heading, hide or show certain elements, update a form in real time, or respond to user interactions like clicks and key presses. So this is how we can make our web pages dynamic. Now for phase one, or within phase one, you really want to just learn enough to be able to create something that is interactive but simple. And that's what the next project will be. It could be something like a quiz, a modal, a password generator. I actually have a course called 50 Projects in 50 Days with all kinds of simple projects like this if you're interested. So learning a CSS framework at this point, I would say, is optional but recommended. And these are used to streamline the process of styling websites and applications by providing predefined CSS classes to use in your project. That way you don't have to create all your CSS from scratch. Now, I would say learn it because they're pretty easy to learn. It shouldn't take long. You don't need to memorize all the classes. You can always look them up in the docs. I mean, that's something I still do to this day. Just learn how to implement them. And Tailwind CSS and Bootstrap are kind of the main CSS frameworks. I would definitely suggest learning one of those two or both. Tailwind is very low level, so there's basically a class for every CSS property. This allows you to have a lot of freedom and customization in your layouts, but the downside is you do end up having a ton of classes in your HTML. Now, Bootstrap is high level, where you can use classes like button or card or alert, and it applies a bunch of styles and properties with a single class. So the upside is you don't have as many classes, but the downside is that many Bootstrap sites can start to look really similar and not as original. I personally recommend Tailwind, but everyone's different. Also, I have 8+ hour courses on both of those. So that's going to be the end of phase one. And at this point, you have options like taking on freelance projects. As far as getting hired as a developer with these skills alone, there may be a chance to do that with some smaller agencies, but these days it's pretty unlikely. You could try, however, if your main goal is to become a full stack JavaScript developer, I would say stay focused on learning and move on to phase two, which focuses on the front end. Later, you're going to learn server-side coding to handle things that the client side or the front end can't do, such as storing data, handling authentication, processing payments, and securing private information. However, there's still a lot to learn when it comes to the client and the UI, which is the front end. And these days, user interfaces have gotten pretty complex, and being a front-end developer involves a lot more than it used to. So first off, you'll want to dive deeper into JavaScript. I know you can create some simple interactive elements, but you'll need to know more than just DOM manipulation. And this includes all the functionality that ES6 gave us, which was a very important update to JavaScript, things like modules, arrow functions, destructuring. The front end includes working with backend APIs, so you need to learn how to use fetch and make requests to a server. This also includes learning the basics of HTTP, because even though you're not creating a backend server yet, you need to know what type of request to make. and what HTTP status codes are and things like that, how to deal with the responses that you get back from a server when you make a request. And this includes learning about promises, async await. Another thing you'll learn at this point is NPM, which is the Node Package Manager, and that's used to install packages which are basically just third-party libraries that you can utilize. Now, once you learn enough JavaScript, you can jump into a front-end framework like React, Vue, Svelte, Angular. Those are kind of the big ones. These frameworks allow us to create much more complex front-end UIs, user interfaces, and applications utilizing things like routes, life cycles, state changes. Components are a huge part of these frameworks. So instead of looking at a web page as a bunch of HTML with some CSS and some classes, you're breaking the interface up into components that have their own life cycle and state or data. So a search box, a menu, a form, you're going to look at all of these as separate components on the page that you have that all work together. And this is how you can create really dynamic applications that are really organized. Now, the framework that you choose is up to you. This isn't a video where I'm going to compare frameworks. Everyone's different, and it's all about preference. Yes, I'd say React is the most popular, but that alone shouldn't be what makes you decide, what to use. I would suggest watching my YouTube crash courses on all the ones that I named and kind of see which one seems like something you could work with and just feels right. Once you choose a framework, there's a whole ecosystem of software that comes along with it. So you'll be learning that stuff kind of simultaneously. State management is essential in handling data and UI changes. You have component state, which is data that is relative to a single component. So let's say you have like a modal component. It may have a piece of state called is open, and that represents if the modal is open or not, and it can be true or false. So that only matters to that specific component. But then we have global or app level state, which pertains to the entire app. So if we have a to-do list, the to-dos, the data that make up the to-dos that we get from the API or the database, those would be put into global state for multiple components to access. So they're not related to just a single component. Now, most frameworks have a built-in way to manage global state, but there's also third-party state management libraries like Redux, Zoostand, and many, many more, which you may or may not need for certain projects. Now, once you have experience with a framework, build some kind of application with an interactive UI. So some examples would be like a calorie tracker, an event scheduler, a budgeting app, something where you can add or change data and submit a form or some other event that triggers state change. And at this point, you're not going to be dealing with databases. When I say store the data, I mean just within a variable or within an array, or you could also use like local storage. There are some front-end methods of storing data. Another project that I would suggest is a front-end app that communicates with a third-party API. This could be like the GitHub API, the Twitter API, or there's many, many public APIs that are available that you can use, and this will get you comfortable with fetch and HTTP. All right, so once you learn the front end, again, you have the choice to look for a front-end developer position. However, this guide is for people that strive to be a full-stack developer. So now it's time to get into the back end. And what I mean by back end is the part of the application that runs on a server rather than in the user's browser. The backend is responsible for handling data storage with databases, authentication, security, and basically everything that happens behind the scenes when a user interacts with your app. And you can build really complex UIs in the front end, but if you need to access data or do any kind of intensive operations, then you're going to need a server. So if you want like an e-commerce website or a fully functional blog or something like that, you're most likely going to need a back-end server. Now, when it comes to backend development, you can use just about any programming language you want. You could use PHP, Python, Java, C Sharp, and many more. However, if you're going to be a full stack JavaScript developer, then you're going to need to learn a JavaScript runtime such as Node.js. This allows you to use JavaScript as your language in the back end. And there are other runtimes like Dino, Bun.js, Encore, which all look pretty promising, but Node.js is definitely the king of back-end JavaScript, and it has been for a while. So you definitely want to dive headfirst into Node.js, along with the understanding of HTTP and REST APIs. Your backend doesn't deal with the browser or the front end or the client at all. So when you get data from the backend, you only get JSON data. You get JSON arrays and objects. Then later you have your front end make a request to your backend to get that data, and then you can use it within your front end in your interface. Now, you can learn the core modules of Node.js on their own. It's really difficult, though, to create anything substantial with just Node.js. So this is where you want to learn a backend framework. And there's a lot of them. There's like Adonis, Koa, Happy. There's countless others, but Express is the big one, and that's what I would suggest learning. And once you learn Express, you can pick one of those other frameworks up pretty easily because they work pretty much the same way, just a little bit of a different syntax. So Express allows you to easily create back-end routes or endpoints, which are like URLs that your front end can hit to get data or send data. And then in your backend, you would run functions to do certain tasks like interact with the database. Again, the data that is returned from the server or the back end is going to be JSON data, and then your front end takes over from there as far as the interface. That's kind of the workflow. Now, you can render views on the server if you want using a template engine like Pug or EJS, but that's kind of the old school way of doing it because you don't get that interactivity of a front-end framework with state and components. The other option you have is to use SSR or server-side rendering with a framework like NextJS, which I think is probably the best option. It's really gaining traction, but I would definitely suggest learning the traditional structure of a full stack application where you have a separate front end and a separate back end. I would suggest learning that before jumping into Next.js. Now, of course, you'll be using a database to manage your data. There's all types of databases, but the two main types are relational and NoSQL. Relational databases are traditional databases with rows and columns. My favorite relational database is Postgres, but MySQL is another option. For NoSQL databases, I'd say MongoDB is the most popular. It stores data in documents, which are basically just JSON or what we call BSON objects. And the type of database that you choose really depends on you and your project. Relational databases provide more structure and is what I prefer most of the time, but NoSQL or NoSQL databases, they offer great performance for unstructured data. And I have a video explaining both types on my channel if you want to look that up. Now, as far as where these databases are stored, you have a lot of options, and it can depend on where your project is hosted. What I would suggest doing is using a cloud database. For instance, MongoDB has a cloud platform called Atlas. So instead of your database being hosted locally, it's housed on their servers. And this is definitely the more common thing to do these days because it's easier to manage. It's not local on your machine or your server. Scaling is basically just a click of a mouse if you want to upgrade your storage or whatever. For Postgres, I've been using Neon database. You basically set it up through their interface and just plug the database URI into your app and you're ready to go. And you can use it in development and in production. You also have all-in-one cloud platforms like Firebase, Supabase, AppWrite. These are all great options that not only include storage, but also a complete authentication solution for your apps. So back in the day when we created projects that used a database, we would learn SQL or SQL, and we'd use raw SQL queries in our projects, in our code. So select, insert, delete, update. This was tedious and not very secure. It's easy to screw things up that way. I still suggest learning SQL in case you need to use it within your database management system or within the terminal. But we use something called ORMs, or object relational mappers, that provide a layer of abstraction with methods to use to interact with the data in your database through your application. So for instance, if we needed to get all the blog posts, we would use a method like post.find or post.findAll instead of a raw select query. And all the necessary security precautions are built into that ORM. Prisma is one of the more popular ORMs in the JavaScript world, and it can be used with many different databases. And what's nice is you can actually swap out, let's say, Postgres for MySQL just by changing a value in the config. The rest of the code stays the exact same. That post.find method will work regardless of database. Now for MongoDB, there's a great tool called Mongoose. It's actually an ODM instead of an ORM because it's not relational data like Postgres or MySQL. Instead, it's an object document mapper, an ODM, because MongoDB stores data as JSON-like documents rather than relational rows and tables. So for one of the first backend projects, I would suggest doing a REST API. I already talked about what that is. You create endpoints for certain tasks in a very specific structure using HTTP requests. I think building something like an API for a blog or any kind of CRUD data is a great idea. CRUD stands for create, read, update, and delete. So your API should be able to do all of that with whatever resource you're using, whether it's a blog post, to-do, a workout, whatever the resource is. Now, once you learn how to create backend projects and REST APIs, you should learn how to deploy them. It's a little more complex than the front end because you need a server, right? You have a few options. You could use a cloud database like DigitalOcean, Linode, Vultr. These are all very similar. They're basically just Linux instances. So you have a bare bones Ubuntu installation or whatever distro, and you set up everything from the web server, so whether it's Nginx or Apache, to installing Node.js. You do everything as if it were your own machine, and it's just a virtual machine. So this can be pretty complex and intimidating, and it's not great for beginners. Like I said, it's a great option because you can do so much. You have a ton of freedom, but it's pretty difficult to get into. So you also have something called a PaaS, or a platform as a service. Some examples of this would be Heroku or Render. These are comparable to Netlify and Vercel, but for a back end and full stack. So whether you're using Node.js, Python, Ruby on Rails, whatever, these platforms as a service, they have the capabilities that cloud hosting offers, but you don't have to do everything yourself. You don't install the operating system, you don't install Node.js and all that stuff. It does all that for you, and you just push your project from GitHub just like you would with Vercel or Netlify. And this is the route that I would suggest you take when you're getting started. Render has a free tier that you can learn with. Heroku used to, but they stopped the free tier, I think, a couple years ago. All right, so once you learn the fundamentals of the back end, you're ready for full stack, meaning you connect your front end and back end. You learn how to structure your projects so that you have your front end folder and your server folder. And in your front end, you would have your React installation or Vue or vanilla JavaScript, whatever it is you're using in your front end. And in the server, you would have your express routes, your models, and so on. I would say my MERN Ecommerce course is a good example of this, creating a full stack application that is, I wouldn't say advanced, but beyond just beginner. Now, in the process of learning full stack, you're going to learn about authentication. And obviously, you're going to need user accounts if you're building something like an e-commerce website. You need users to create an account and log in, and of course, that needs to be a secure method. And you have all types of options. You can use sessions and cookies. You can use something called JSON Web Tokens, or JWT, where the server generates a token that gets sent to the client, and then after a user logs in, that token is sent to the server for verification. Or you could make it easier on yourself and use an authentication library like Passport or something like Auth0. There's way too many options to list. Just make sure that you not only secure your front end and your routes, your UI, but also your backend API. Just because a user can't go to /dashboard doesn't mean that they can't go to your API, whatever route that dashboard hits, and then get the JSON data that they're not supposed to. So there's a lot of security involved when you get into full stack development. Now, once you learn authentication, you're ready to create a real full stack project. And you can use a course like my MERN Ecommerce course or somebody else's course, but I would suggest creating something from the ground up that is your own, because that's going to give you the real experience. All right, so now we're going to talk a little bit about SSR, or server-side rendering, and that would include frameworks like NextJS, which is based on React, or Nux.js, which is based on Vue. You also have SvelteKit. Angular has SSR capabilities. This is just another way to build dynamic websites, and you could technically learn this right after your framework like React or Vue, since it is front-end focused, but there are also a lot of back-end principles involved when working with this SSR architecture. So it makes sense to cover it here, in my opinion. Up until now, we've been talking about the traditional setup where the front end and back end are completely separate. And this setup is usually referred to as a single page application, or a SPA. So when you visit a SPA website, the UI is loaded once on a single page, and then the client or the browser takes over, right? So everything, including the routes, is bundled in the front-end JavaScript. That means that when you click on a link to go to, like, let's say /about, you're not actually making a request to the server for the about page. Instead, the JavaScript framework simply loads the correct components or correct views for that route without refreshing the page. Now with SSR, things work a bit differently. When you visit a link, that request goes to the server and the page is dynamically rendered before it's sent to the browser. So instead of downloading a large JavaScript bundle, that manages routing and rendering on the client side, like in a SPA, the server actually generates a fully rendered HTML page for each request. And this means that the first thing the user sees is a complete page rather than an empty screen waiting for JavaScript to load and build the UI. So there can be some performance advantages to SSR. Some other benefits are SEO. So since the page is pre-rendered on the server and it's sent as full HTML, search engines can crawl the content more easily. And it also means that the website loads faster, especially on slower devices, because the browser doesn't have to do all the heavy lifting to render the page. And even though SSR renders pages on the server by default, you can still have client-side components just like you would in a regular SPA. And it really gives you the best of both worlds, combining the flexibility of the client side with the speed and efficiency of server-side rendering. So I would suggest building a good size Next.js or Nux.js project or SvelteKit. I actually have 2 project-based Next.js courses, Next from Scratch, where we build a property management website, and Next Ecommerce, where we build a shopping website. All right, so I'd say if you learn everything or most of what we've talked about, then you're more than ready to start working as a full stack developer. So now you want to focus on career development. And for most of you, that'll be getting a job. And for some of you, that may mean freelancing. Like I mentioned earlier, I will have a freelancing guide later on in the year where I discuss technologies that are best for freelancing. Now, before you apply to any jobs, you want to make sure that you have a strong portfolio with 3 to 5 well-rounded projects that can demonstrate your technical skill and creativity. And you can use course projects, but I would definitely suggest building something on your own, or at the very least, customizing those course projects. You want to ensure that your projects highlight things like responsive design, full stack capabilities, API integration, authentication, things like that that will impress potential employers. And you also want to have a good GitHub profile with all your code. So this is one that a lot of people overlook. Work on your web presence and professional social media accounts. Brand yourself online. It will increase the chances of you being more discoverable and reputable. And this is kind of a must if you're freelancing or starting your own business. In addition to your website portfolio, optimize your LinkedIn profile, your Twitter, your GitHub, even something like having a YouTube channel or a blog to show that you're passionate and knowledgeable. It's a good idea, and it will separate you from a lot of people in the industry. You know, if you're self-taught and you don't have a degree, then I can't stress this enough, because this is your proof. You don't have that degree, so you have to show them other ways that you know what you're doing and that you love what you're doing. Now, once you have your portfolio website, your GitHub profile, your web presence, start doing a bit of interview preparation. And this includes working on your presentation as well as interview questions. And I have a course called 70 plus JavaScript algorithms and data structures with a lot of the common problems that they have you solve in interviews. So this can help prepare you. Now, freelancing is another option, whether it's your main goal or just something to help you develop practical experience. You can use platforms like Upwork and Fiverr. You can find, small projects. You can enable further development of your skills in real-world scenarios while earning an income. Now, once you get a job or start freelancing and you're working with other developers and or clients, work on your soft skills. Working on your own is a completely different experience than collaborating with other developers, and nothing can really prepare you for that except just doing it. You may be like me and have social anxiety, but you'll have to kind of push yourself, and after a while, it'll get much easier. I started freelancing. That was the first thing I did, and dealing with clients was absolutely nerve-wracking, but I just pushed myself to do it. Same thing when I started working at a job with other developers. It was, really awkward and weird at first, but I quickly got used to it. And it really helps if the people you're working with are helpful. So phase 5 is continuous learning. So no matter where you're at in your career, you'll always be learning something new. Tech is always changing, and you just need to learn how to adapt. So I would say continue with advanced front-end development. You're going to learn a lot of this stuff on the job as well as with your own projects. And I would say try to master the framework of your choice as well as its ecosystem, including SSR, state management, high-order components, build tools, and other advanced topics. Now, testing and debugging is something that you'll dabble with in the early phases, but once you become a real developer, you'll want to dive into this stuff more. And this includes unit testing with libraries like Jest, as well as using tools like Sentry for debugging and error tracking. It may seem like extra work at first, but once you get the hang of it, you'll see how much you actually benefit from it, and it does save you a lot of time in the long run and a lot of aggravation. Now, in addition to advanced front end, learn more on the back end side as well. Learn things like microservices, which are small independent services that communicate with each other to form a larger application. Instead of having one massive back end handling everything, microservices break it down into smaller self-contained units that handle specific tasks. So for example, in an e-commerce application, you may have separate microservices for handling users, products, orders, and payments, each running independently but communicating through APIs. And this approach makes applications more scalable, more maintainable, and just overall resilient. Now, we talked about deployment and some of the platforms that are available. You may also want to look into DevOps and containerization with Docker, because containers allow you to run your code in a consistent and isolated environment that you can share across different machines and operating systems. And this can be ideal if you're working with a big team. You can look at setting up continuous integration and continuous deployment, also known as CI/CD. This means that you're automating the process of testing, building, and deploying your applications whenever you make changes to your code. Finally, and if you're freelancing or starting your own business, some of this stuff may not pertain to you. Like if you're doing WordPress websites, you're not going to need to get into Docker. But again, this is geared more towards the full stack JavaScript developer that wants to work for a larger company. So finally, I would suggest building your own SaaS or software as a service. So a SaaS is a web-based application that provides a service to users, typically on a subscription or pay-as-you-go basis. Instead of users downloading and installing software on their devices, they access it through a web browser. Some well-known examples of a SaaS are Dropbox, Notion, Trello, Stripe. Obviously, you can create something much simpler, but I would recommend making this your sole personal project that you can hopefully one day turn into a large income. Even if you're working as a developer doing a 9 to 5, it's good to have a personal project like this. It keeps your skills fresh and it breaks away from the monotony of your 9 to 5 job. All right, so I know that was a lot. Try not to let it overwhelm you. You want to take it one step at a time. You can download the presentation, start with phase 1, put up only the screen you're working on and focus on that rather than looking at this as a whole. And even if you already know a good amount of HTML and CSS or whatever it is that you already know, go back and get a refresher and maybe do a couple small projects. And before you know it, you'll be through the whole thing and be working your dream job. So that's it, guys. If you watch this whole video, I really, really appreciate that. I'll have my courses in the description if you're interested in that, and I will see you next time.